Okay, so in this case, we're given a string, and okay, I actually first just want to look at the example because I think it explains itself pretty well. So we've got A, B, 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 C, and we basically replace the AA with 2A. We replace the 3 consecutive B's here with 3B. And then the C, we don't bother with a 1C, we just call it C. Okay, so formally, what we're trying to do here is we're dividing the string into disjoint substrings consisting of identical characters. Okay, we'll look at another example in just a sec because there is another point I want to make. Okay, and then next, each of these substrings, so like the AA, the BC, BB, the CC, they're going to be, if their length is greater than 1, they're going to be replaced by the number of them and then the character itself. And then we're going to concatenate them together. We're going to join them to make something like this. Okay, cool. Now, something I did want to say is it's not like some of the ones we've looked at before where we're just looking at like how many A characters are there in total in this whole string. It's a matter of like consecutive characters. So like we don't want to be saying 2A just because there are 2 A's total. It's A here and then another A over here. So that's an important thing to keep in mind. Okay, so how are we going to do this? Well, basically what we'll start with anyway is we're just going to sort of loop through this thing and we'll construct the string as we go. We'll make up the line encoding as we go. Okay, so basically we're going to start by saying let encoding be assigned the value of just an empty string. And ultimately, that's the thing that we're going to be returning at the end. And then what else are we going to say? Well, basically what we want to be doing is we kind of want to do something like this, where we loop through the string. So I is less than s dot length and I plus plus. We'll loop through it, and we basically want to say something like, first of all, we'll say this character is going to be s dot character at this index, and we want to compare it to the previous character. So we'll say if character is the same as the last character, I'll define that in a minute. Then what do we want to say? Well, I guess like occurrences plus plus, and I'll define that also in just a minute. Otherwise, what we want to say is, well, first of all, we're going to say last character is now going to be this character, and occurrences is going to be assigned the value of 1, because we're onto a new character now. And the last character is just going to be whatever this one is, so that's going to switch it up. We're also going to put this into the encoding, so we'll say encoding plus equals occurrences concatenated with last character. Okay, so basically what I'm trying to say is we're checking if each character matches the last one, and I'll just delete that for now. Yeah, so we're checking if each character matches the last one, and if it does, we're going to increase the number of occurrences. And when we get to the point where it's no longer matching, we're going to say, oh, okay, well now we're on to a new character, and we've only seen one of them. And we also want to say, well, for example here, since we're done with the A characters and we're moving on to B, well, now let's put that into the encoding. So we'll put the 2 in there, which is the occurrences, and we'll put the character in there, which is A. The only problem here is we haven't really like instantiated or we haven't declared, last character or occurrences. So we should probably start it out with something. So we'll start with just the first character. We'll say let last character be assigned the value of s at 0. Or just to be consistent with what I have downstairs, s dot character at 0. And we'll let the number of occurrences be assigned the value of 1, because we've only seen one of them so far. And then because of that, we should probably start this at 1 instead of 0, because we've already looked at the first character. Okay, so I think this is looking pretty decent. Let's run that, and we'll see what happens. Okay, so we're noticing an issue with this one, and it's the fact that it doesn't have the C at the end there. And the reason is because we're basically only doing this when we're moving on to a new character. We should probably also do this when we get to the end of the string, so that whatever we have as our last character and that number of occurrences gets added to or concatenated onto the encoding. Okay, but now we have another problem, which is basically that all of these single characters, they have the 1 in front of them. We don't really want the 1 in front of them. So basically, we can fix that. We can do a quick little ternary or something. We'll just say occurrences is greater than 1. And if it is, then yeah, we'll do this. We'll say occurrences concatenated with last character. Otherwise, we'll just do the last character. Great. And let's just get a bit more room so that doesn't bleed on to the next line. Awesome. Okay, and so then let's take this and we'll just replace that with that. Okay, cool. So let's run that now and we'll see if that's going to work. Ooh, you gotta like that. Okay, so let's submit this. We'll see if it's going to pass the hidden test. And it does. Okay, so that's nice. That feels good. And yeah, Alden, I really like this task too. I wasn't really aware that this was something used in data compression. So this is something that like operating systems and stuff like that do then? I just program, man. I don't know that much about computers. Okay, so we've got this version done. It worked. It passed all the hidden tests and stuff like that. But could we do better? I mean, like, we're talking about strings here, right? There are lots of ways we could do this. We could do an implementation that basically does this, but I think that's probably ultimately going to be like more work than what we did here. So let's try to do this in such a way that's going to be maybe less work. All right, so what I was kind of hinting at before when I was saying that we're dealing with strings is basically we're trying to check some property. We're trying to, maybe modify a string in some way. So first of all, checking for properties, looking for patterns, that's regular expressions territory, right? So maybe we're going to use a regular expression here. But the main thing is that we're modifying the string too. So we want to use replace here. Now, I can't remember if we've used replace before or not. Just in case, let's talk about it for a sec. So replace is a built-in for strings. So s.replace, and basically it's going to take 2 arguments. We could say, let's replace lowercase a with capital A, let's just say. Okay, so we'll run that. And the first thing that we notice is it's replacing a lowercase a with a capital A, but not all of them. And we'd probably prefer for it to be all of these things. So this is basically where the regular expression is going to come into play. So we'll say regular expression containing a. Now let's run that and replace that with capital A. Still, it's not replacing all of them, but that's because I'm missing the global flag. So lowercase g means we're going to be looking at all of them. Okay, cool. So we're replacing all of the lowercase a's with uppercase a's now. That's good. I like what I'm seeing. But what if we wanted to replace, like, let's say not just lowercase a, but maybe lowercase a or lowercase b? I want to replace those. Thing is, now it's replacing them all with uppercase a. I would prefer if it sort of replaced them with their own uppercase character, like what the actual character is. So what we're going to do here is for the second argument, instead of just using a string, we're going to use a function. Okay? And the function is going to have for now, one argument. Later we'll put in another argument and we'll see what that's all about. But for now, just this argument called match. It's whatever this regular expression is matching. So like basically each one of these individual characters is going to match. And I think all I really want to do here is return match dot toUpperCase. So that's another little built-in that we sometimes use for strings. And the return here, okay, so just to be clear about how this is going to work, the replace is basically saying we're looking for anything that matches this. Once you find something that matches this, use that as the input of this function and replace it with the output of this function. So that's what we're going to do. Let's run that. And we should expect basically for all the A and B characters to be capitalized. And that is what we're seeing here. Okay, and then, why stop at A and B? We might as well just go all the way from A to Z. And this is pretty much just going to capitalize everything. Okay, cool. So that's working nicely. So replace is really powerful, like we don't have to just do from one string to one other string. Like we can take a whole regular expression and then take a whole function and do stuff with it. So, okay, here's the thing. remember I was saying we could give a second argument to this thing, and that's basically if we want to use a capture group. So let's say we want to capture like whatever character comes before B, let's say. Okay, so that might seem a little strange, but let's run that first of all. And now we find, yeah, okay, so anything that comes before the B is getting capitalized. But here's what I want to do. I want to do a console.log. I want to do match and capture. What's capture? Well, it's the second argument here. So remember, for regular expressions, basically anything in parentheses is going to get captured. So we haven't really done, I don't think, too much with these capture groups, but here we go. So we can see in this string, it's matching two things. So it's matching the AB right here because it's some character followed by B. So it's matching that, but it's only capturing the thing that's inside the parentheses, which does not include the B. So that's why it's just capturing the A here. And then it's also going to match this. So it's going to be BB, but it's just going to take the first B as the actual capture group here. Okay, nice. So this is giving us sort of a framework for how we're going to do this problem, but the thing is this. Okay, let's go over here now. We'll look at our regular expression creator, and we could do something like you know, we could say like A to Z, and that's going to match any character like A or B or C or whatever. It's going to match any of those. And we also have something like if we were to put a plus on it, so that means it's going to match one or more of them, which is kind of like apropos to what we're trying to do in this problem, right? Because we want to find like if there's a bunch of A characters, we want to match that, we want to capture that, do something with it. The problem with this is it's looking at this a little differently. So notice how it's matching this whole thing, and it's because it's matching any character and then one or more of those. So they don't all have to be the same character. That's the thing. Okay, so is there a way to tell the regular expression that we actually want like a consecutive string of the same character occurring? As it turns out, yeah, there is. What we're going to do here is we're going to get a capture group, but then with that capture group, we're going to do something a little interesting. We're actually going to refer to the capture group inside the regular expression. So since this is the first capture group, we're going to refer to it as \1. Okay, so \1, it matches the same text as most recently matched by the first capture group, which is basically just this over here. Okay, so that means if I were to do oh, okay, so it's matching the AA here. If I wanted to match this whole thing, I need to put a plus on that. And there we go. So the full match is the AAA. The group one is just the single A. But then if I were to put like BBB or something like that, now this is a different match. They're not all part of the same thing, which is cool. And you know, it could just be like C or some other stuff. Thing is, unless we have more than one of them, it's not actually going to match. So we could instead use the asterisk, so that instead of like one or more of these additional capture groups, it would just be 0 or more. So then it actually would match even just a single character. But I am actually going to keep it like this for now, because we actually don't want to modify the things that are just single characters. They can stay as they are. What we want to modify is the things that are multiple instances of the same character. Okay, cool. So this is what we're going to use. And let's get that into here now. So that's our regular expression. And yes, the global flag is that it'll match all of them. And now, since the capture group here is basically just the single character, like, you know, it doesn't matter how many of these things there are, it's just the like one copy of them. I'm actually going to stop calling it capture, and I'm going to call it character. So, character. And for now, I guess we'll just return like an empty string or something like that. I want to take a look at the console logs and see if that's working. Awesome. So it's got the double A, which is being, it's capturing that single character A. The triple B, it's capturing the single B there. So good, this is good. Now, what do we want to be returning? What do we want to replace this with? Well, basically match.length, which is not mask, match.length, which is basically like, you know, the length of this thing, how many of that character were there. So it's that, and then we want to concatenate that with the character itself. Let's give that a run, and then we'll see if that works. Ooh, and yeah, it does. Okay, so you got like that. I'm going to get rid of the console log because we don't really need that anymore. And now I'm noticing this is just like a one-line thing. It's just a function that simply returns something. So I'm actually just going to replace it with an arrow function. So match and character gets mapped to match.length plus character. And I am really starting to like the look of this. So let's run the test. We'll see if that still works. And it does. Okay, so that's pretty nice. I mean, if you take a look at like what we're replacing, this was a lot of lines of code. There's a lot of stuff we had to sort of consider here. Like, I felt like there were a lot of exceptions that we were considering with this first attempt. You know, like we had to first set this up, you know, say the initial conditions for last character and occurrences. We need to ask ourselves, is occurrences happening more than once? And then we needed to basically just repeat the exact same line, which I hate doing, after we complete the loop. So I think this is a lot better. Really nice one. Is it passing all the hiddens? Let's find out. Oh, and yeah, it is. Okay, so that's a great feeling. I feel good about this one. We've successfully encoded all these lines. So I think that's about all I have to say for this one. Yeah, I guess we'll finish up there. Let me know if you have any questions, comments, or concerns.